Hi, today on Periodic Perfection, I'm going to be talking about voltaic cells. We're going to go through a voltaic cell, we're going to label a voltaic cell, we're going to talk a little bit about its functions. So a voltaic cell, first thing to notice is it has two half cells. The cells are the site of oxidation and reduction. Part of what we're going to do in just a moment is figure out which cell is doing which. So for our purposes today, our cell here on the left is going to have a zinc electrode in it, and our cell on the right is going to have a copper electrode. This is your electrode. The electrode is made out of solid metal. So our electrode on our left side here is zinc. Our electrode on our right side here is copper, and they are solid metal. They are surrounded by a solution that contains ions, one of which is the metal, the other one is usually a negative polyatomic. So on this side, on the left, our solution is zinc sulfate, and on the right, our solution is going to be copper sulfate. So both of them contain sulfate as our negative ion. Both of them contain the metal that matches the electrode in their side of the solution. In order to figure out which side is going to be oxidation and which side is going to be doing reduction, I go to table J. I'm going to find copper and I'm going to find zinc. My zinc is higher than my copper, so that means that zinc will be oxidized and my copper will be the site of my reduction. Because this is a voltaic cell, whatever is higher on table J is the thing that gets to undergo oxidation. Coming back to our diagram, we have our side with our oxidation. This is our anode. Our anode always undergoes oxidation. Easy way to remember that is an ox. Now, another thing to point out, our anode is always a negative charge in a voltaic cell. One way to remember that is anode. Looks like an ion. Anions are also negative, so our anode will be negative. On this side, we have our cathode. You might think, well, cathode kind of sounds like cation. Cations are positive. This side will be positive. Our cathode will be the site of our reduction. A way to remember that is red cat, reduction at the cathode. Now, let's talk about the function of this voltaic cell and what it actually does. Because we have oxidation going on here in the anode, that means that we are losing electrons. Oxidation is losing. So when this reaction actually starts up, what happens is our electrons are lost from the zinc. So we essentially have this reaction going on. Zn yields Zn plus 2 plus 2 electrons. These are electrons that are going to come off of the zinc. So we're going to have electrons coming off of the zinc and traveling through the wire over here to our copper side. So it's going to be our electrons are moving in this direction. Whenever an electron gets lost off of our anode, it comes off of a zinc atom, and that zinc atom forms a zinc ion. So you have zinc ions coming off of our zinc bar and forming zinc plus 2 ions in solution. That's going to be really important to us later. That causes over time this zinc anode to kind of get whittled away. It gets eaten at slowly as the oxidation occurs. because every time 2 electrons come off, one zinc atom is being turned into a zinc ion and it's being removed off of the anode and it's going into solution. So gradually this gets smaller and smaller and smaller. If that keeps going to the point where this anode is completely gone, then the voltaic cell will stop functioning. Let's come over to this side. We've got our electrons going down here to our cathode. And when they reach the copper cathode, they come onto the copper cathode and they start building up a little bit of a negative charge. When that happens, our copper +2 ions are attracted to that and they end up attaching to the outside of the copper cathode. So each copper ion can accept 2 electrons because its charge is +2. So these 2 electrons will attach to our copper ion. It then coats onto the outside of our copper electrode. So as our zinc electrode gets smaller and smaller and smaller, our copper electrode is going to get bigger and bigger and bigger because every time 2 electrons come down it, to a copper ion is going to attach to it. Now let's talk about this bit in the middle. This is our salt bridge. The salt bridge maintains electrical neutrality of our system because every time that we have electrons coming off of our anode, it makes the anode more positive because we have these positive zinc ions coming out into solution. So we need to have negative charges moving this way. So we're going to have sulfate ions moving that direction. Every time we pull a copper ion out of solution, its positive charge is going to need to be replaced. So we are going to have sodium ions or zinc ions moving this direction through our salt bridge to replace those positive charges. This is really important because you don't want a buildup of charge on your system. You want it to remain electrically neutral. Okay, now our oxidation reaction was this. Over here we've got our reduction. Remember Rig. Our reduction equation is going to be Cu +2 plus 2 electrons yields Cu free state. So that is our voltaic cell. When it is running, we generate electricity. A voltaic cell is a battery. That is the basics on a voltaic cell and how a voltaic cell works. If you'd like more info, check out one of the other tutorial videos that I've posted today. Have a great one. Bye.